Hello, good day again everyone. Welcome again to CE 3 to 11 Principles of Steel Design. So in this pre-recorded lecture, this would just be a continuation of our last pre-recorded lecture, which was about the analysis of tension members. Okay, so for our illustrative problem here, problem. Determine the load capacity of the angle used as a tension member as shown below. The bolts used are for diameter 19mm bolts and use A36 steel and standard gauge distance for angles. Then neglect block shear. So as you can see in this particular problem right here, kung ano bang pagkakaiba niya sa last problem natin is that its connection is staggered, and by staggered makikita mo they are not actually aligned. So they don't fall in one particular line. So magkakaiba sila, so thus they are staggered. Okay, if we are to deal with analysis problems, the first thing that we should do is to list all the parameters given or the properties. Basta yung given. So, dito, it is said here that our angle is to be of 200 by 150 by 16 mm. So, it is an angle. And next up, ano ba yung property na gagamitin natin? So, it is said here that we are to use a 36 steel. So A36 steel. So by that itself, we should know what is the yielding and the rupture strength of our particular steel. So that is to be Fy and Fu. And kung hindi nyo pa memorize kung ano yung Fy and Fu, we should look at our reference file right here. So this is to be the ASTM specification. So na-circlean ko na dito. Ang gagamitin natin would be A36. Thus, our minimum yield stress would be 36 KSI and our tensile stress or the ultimate tensile stress would be 58. So this is the stress that we would be using for rupture. So with those, I would just be listing them here. So this is to be 36 kips per square inch. And this is to be 58 kips per square inch. But since we are in the Philippines and we use SI unit as in our computations, we must convert this to SI units. And in SI units, this should be written in megapascals in pressure. Okay, so for us to convert this, just multiply this by our conversion factor of 6.895. So times 6.895. And whatever the answer is, let us round it to the nearest whole number for the ease of computation in our classroom setting. So sa lessons natin and sa mga quizzes nyo. So that is to be 36 times 6.895. So this is to be 248 megapascals. And as for our Fu, that is 58 times 6.895. And that is to be 400 megapascals. So once again, I have rounded it to the nearest whole number. Okay, next up, ano pa ba yung kailangan natin? It is said here that we are to use standard gauge distance. So ano ba yung mga yon? So as you can see here, 40, 50, 50, and 50 are already given. So ano pa yung mga kailangan natin gauge distance na yan? It would be this. It would be K, L, M, and N. So hindi nga sinabi kung ano yung mga distances na yan. So it would be our duty to know what those distances are. So if you can remember our reference file right here, this would be the workable gauges of angles in inches. So ito. So, and as you can see here, it is said that it should be in inches. Kung itong basis na to, these are all in inches. So from here, ang angle daw natin is 200 by 150 by 16. And if we are to convert this to the nearest inches, so 200 by 150 by 16. So ito lang actually yung kailangan nating malaman. So itong length na to and itong length na to. So as you can see, this would be the longer part. So this is to be the 200 millimeters. Di mo lang nakikita. And this is to be the 150 millimeters. Okay, so convert muna tayo. Divide this by 25 or 25.4. So 200 divided by 25.4 is that is approximately equal to 7.8. So, actually, ang gagamitin natin dito for 200 mm would be 8 inches. And for 150 mm, that is to be 6 inches. So, gagamitin natin conversion factor dito is just 25. So, 200 divided by 25, that is to be 8. Then, 150 divided by 25, that is to be 6. So, meaning in our reference right here, ang gagamitin natin would be 8 and 6. So, ito siya. 8 and 6. So, meaning, itong side na to, gagamitin natin dyan 8 inches and itong gagamitin natin 6 inches. So, that would be its English counterpart, I mean, English equivalent, I should say. Okay, so paano natin magagamit tong table na to? So, this would be the figure that we are to consider. So, itong G, G1, and G2. So, itong G, G1, and G2. But in our figures, sabi dito, dalawa siya, no? Dalawa yung connection natin. So, with that, ang gagamitin natin dito is G1 and G2 only. Itong G na to, gagamitin lang natin yan if and only if we only have one connection per leg. Pero as you can see, dalawa sila. So, how can we use that? So, ito muna, no, dito muna tayo sa leg na 8 inch. So, doon tayo sa longer side, which is, let's say, this. Itong longer side na to. Okay? So, 8 inches daw. And since dalawa yung connection natin, ito yung spacing ng G1 and the G2. So, that would be this, G1 and G2. Okay, so our spacing for that side would be itong K and L. Sulat ko na lang. So, for K and L, that is to be 3 inches and 3 inches as well. So, ito siya, no? 3 inches and 3 inches as well. So, that is to be K and L. So, what about for M and M? Since this side right here is actually equal to 6 inches, 6 inches nga daw ito, di ba? Kasi 150 mm yan, so 6 inches. Titignan mo ngayon yung table na to sa 6 inches. So, that would be this. So, ngayon, dun sa side na yon, dalawa din yung connection natin, which is this and which is this. So, gagamit din tayo ng G1 and G2. So, we would be using 2 and 1/4 and 2 and 1/2. So, yung 2 and 1/4 daw natin yung sa una, tapos 2 and 1/2 yung sa pangalawa. Okay, so, sulat na ulit natin dito. So, this is to be, let's say, okay. So, for M, ano na rin yung M natin? That is to be 2 and 1/4. Tapos, yung N natin is to be 2 and 1/2. Okay. 2 and 1/4. And this is to be 2 and 1/2 inch. So, what we would be doing now is to convert this into millimeters. So, multiply this by 25.4, our conversion factor. 25.4, oops. 25.4 millimeters per inch. So, magka-cancel out yung inch. Pero hindi ko nasulat yung unit because we need space for later. So, our answer here would be 3 times 25.4. So, that is to be 76.2. But let's round it to the nearest whole number once again for the ease of computation. So, 76 millimeters. So, parehas na itong dalawa, 76 millimeters. So, this is to be 76 millimeters and this is also to be 76 millimeters. And as for letter M here, this is to be 2 and 1/4. Diba natin na i-convert? So, multiply this by 25.4 and multiply this by 25.4 as well. So, this would give us answers of 2.25. So, this is to be 2 and 1/4 times 25.4. That is to be 57.15. But we would be rounding it to the nearest whole number once again. So, this is to be 57 millimeters. So, as for the second one, so 2.5 times 25.4. So equal sign, our answer here would be 63.5 millimeters. So rounding it off to the nearest whole number, that is to be 64 millimeters. So this is to be 57 millimeters and 64 millimeters respectively. Okay, so erase ko na muna to. Ilista natin sa taas para malinis tayo. Okay. So from that, our K, L, M, N is equal to, okay, once again, they are 3 inches, 3 inches, 2 and 1/4 inch, 2.5 inches. So this is to be approximately 70, ano na yan, 76. This is also 76. This is to be 57 and this is to be 64. All of those are in millimeters. Okay, so next up, let's get the standard hole of this. Okay, so for our standard holes, this is to be our solution. So first, it is said here that the bolts that we are to be using are diameter 19 mm. So diameter 19 mm bolts. So once again, if this is to be your bolt, hindi pwedeng yan din yung butas mo kasi hindi siya magkakasya. So of course, for the nominal hole size, we must add 1.6 millimeters or 1/16 inch to that to the bolt for it to fit in the hole. But once again, in our computation for our computation parts in our quizzes and in our lessons, we would be using 2 mm instead. Kasi ito, pag kinonvert mo to in mm, this is actually, so i-convert na lang natin, 25.4 times 1/16. So that is to be 1.6. But in our lesson, once again, and in your quizzes, you would be using 2 millimeters. So 2 millimeters. So diameter of the nominal hole is equal to 19 plus 2. So that is to be 21. Okay, pero sa totoo lang, this should be 1.6. 1.6 siya kasi yung code natin is 1/16. So, rinound up lang natin siya 2 mm. So, that would be the nominal hole, the diameter of the nominal hole that we would be using in our lessons and in your quizzes. And as for the diameter net, so once again, after you have solved for the diameter of the nominal hole, as per NSCP provision, magdadagdag ka ulit ng 2 mm. So, that is to be the nominal hole plus 2. So, that is to be 21 mm plus 2. So, this is to be 23 millimeters. So, this is the diameter of the hole that we are to be using in our computations. So, now that we already have those, let's proceed with the next step. So now that we have already listed all the parameters needed for our problem right here, the first thing that we should solve now is the gross sectional yielding strength. So just like the last time, so for yielding, so for us to get the nominal strength for yielding, that would be Pn is equal to Fy times Ag. So, ayan. And ano ba yung meron na tayo? Meron na tayong Fy. Do we have our Ag? So, not yet. Let's solve for Ag. As for the area gross, that is to be the whole area here. So, nasan ba yung highlighter ko? So, that is to be this whole area. So, yung angle, cross-sectional area ng ating angle. And gross, so hindi pa natin nababawas yung ating mga butas-butas. Kayo naman bahala kung paano nyo kukunin yung area na to, but In my case, I would be doing it this way. So I would be adding 200, let's say plus 150. So ito, no? Okay. So 200. Itong 200 na to. Plus 150 minus 16. So minus 16. Ayan. Kanya-kanyang diskarte kung paano nyo makuha yung area ng angle na to. But in my case, I would be doing it this way. So, okay, 200 plus 150 minus 16. So, yan na yung length. Then, I would be multiplying it by the thickness. So, that is to be 16 as well. So, solving for our area right here, that is to be 200 plus 150 minus 16. So, times 16. So, that is to be 5,344 square millimeters. So, meron na tayo ngayong AG. So, for us to get the value of PN, our PN would now be equal to AG. Then, that is to be, ano yung FY natin? That is to be 248, no? So, 248 megapascals times 5,344 millimeters squared. So, multiplying those, we would be arriving at an answer of 248 times 5344. So, that is to be 1325312. So, 1325312 newtons. So, that is to be your PN. Pero, nominal yan. Ang kailangan nating mahanap is yung allowable strength and yung design strength. Pero okay, so this time we won't fail. Parang the last time nagkamali ako, no? So for LRFD, our design strength would be phi Pn. So that is to be Pu. Pu is equal to phi Pn. So this is to be 0.9 times Pn, which is 1325312. So solving for the design strength, that is to be 0.9 times 1325312. Tama ba? 1325312. So that is to be 1192780. So 1192780.8 newtons. So if you are to convert this into kilonewtons, divide nyo lang na 1,000, tapos ayun na yun. But for this time, that this is to be my answer. Oops, tabi niya, ang pangit ng linya ko. Okay, so this is to be my answer. And as for the ASD, our allowable strength is equal to Pn divided by omega, where omega is equal to 1.67. So this is equal to 1325312 divided by 1.67. So our answer here would be 1325312 divided by 1.67. My answer here would be 7936. So 7,936 newtons. So this is to be my value for the allowable stress in yielding. So this is in yielding only. Okay, next up we would be solving for the rupture strength.